Welcome back. We're in 42C. We're going to talk about constants in exponential functions. We've done these before. They're not difficult. They just take a little bit of time and a little bit of clarity of thought to get through these. Now, the one thing to note here is in exponential functions, the exponent contains the variable and the base can be any number except 1 because then it's a straight line, right? So let's look at example 42.3 and we'll go ahead and if I can get my pen to work today, here we go, 42.3, we will sketch the graph of this function, and the function is y is equal to 3 to the negative x. One of the things that you have to look at when you have these more, that's really what is going on. We're just learning how to do more complex exponential functions. The trick, I won't say it's a trick, it's probably just the first step, is to take this complex exponent and just put it into a form that you understand, something that you know how to do. So for this 3 to the negative x, we would just say, all right, we've got 3 to the negative 1 x. We've just separated them out. Negative 1 times x is negative x. So we know what this would be. That would be 1 over 3 to the x. So that is what y equals. So just transform it into something that is actually readily available for us to calculate using our mental math. So that's what we have to do first. So now we can create our table. So here's our x value. Here is our function 1/3 x. And then here is going to be our y value. So again, I like to use -2, -1, 0, 1, and 2, just to get a good base going. So 1 over 3 to the -2. Well, we know that that is going to be 1 over 1 over 3 to the -2, right? So this is keep it, change it, flip it. Or that's one way that you can do it. And we can say 1 over 1 times 3 over 1, and this is squared. So that would be 9. So that is 9. All right, here we have 1 over 3 to the -1, right? So if we follow the same logic here, then this is going to be 3. Now, 1 over 3 to the 0, that's always, whatever that is always 1. Now, 1 over 3 to the first power is just going to be 1 over 3. And 1 over 3 to the second power is going to be 1 over 9. And we would just graph that. So here, I'm going to do this in pink. We have 0, 1. And actually, I think what I'm going to do, let me Control-Z that. Let's do this so that it makes a little bit of sense to us. This is going to be 1. This is going to be 2. I'm going to skip some lines just to make this a little bit bigger, right? And then this will be 4, just to make it easier to graph for us. So the same thing down here. 1, 2, this would be -1. 1, 2, this would be -2. 1, 2, this would be -3. This would be 1, and this would be 2. And then, of course, this would be 3, but we don't go that far. So let's look at the first one is 0, 1. So 0, 1 would be here, right? We'll think of it like that. So we graph this one. -1 and a +3. So -1, +3 would be here. So we've got that one. Now this one is out of our range, so I'm not even going to try to graph it. I'm just going to leave it alone. Now this one is going to be 1, so here, and 1/3. And this is why I did it in skipping 3. 1/3 is easy to graph right there. There it is. Because that's 1/3 of this 1. So I've got that one graphed, and then I can do 1/3 of this box to get to 2 and 1/9. So there is my graph of this exponential function. And sometimes you have to do that just to get a better curve. You don't necessarily have to have it 1-to-1 ratio. You can split it up and make your lines bigger. So look at maybe doing that on some of those. All right, so let's see. 42.4, let's do it. Now 42.4, they tell us to graph y is equal to 1/2 to the 2x power. All right, well, we don't know what 2x power is, but we know what 2 is, and we know these are factors multiplied against each other. So we know we can multiply this and still have the x left to multiply later, and it would be fine, right? So that's what we're going to do. We're going to separate this out and say 1/2 times the 2 to the x. So then that becomes 1/4 to the x power. Now that is a whole lot easier to solve. So here is our x. Here is our 1/4 to the x. And here is our y. So again, -2, -1, 0, 1, and 2. So 1/4 to the -2 would be flipping that and squaring this. That'd be 16. This would be 4. So 1/4 to the -1 would be 4. This would be 1/4 to the 0. That would always be 1. Or not always 1, but it is 1 here. And then 1/4 to the 1 power is just 1/4. And then 1/4 to the second power would be 1/16. So I'm going to see if I can graph this. Actually, I think what I'll do is I'll just start over here. I'm going to redraw this so we can graph it. You get the idea though. These are not hard. It just takes a little bit of time. It's a little bit tedious. And I think I'm going to use 4 squares for this. So 1, 2, 3, 1, 1, 2, 3, 2, 1, 2, 3, 3. 1, 2, 3, 4. So I'm going to bring this down. So there's my 4. And then I just need the x values to be 1, 2, 3, -1, 1, 2, 3, -2. 1, 2, 3, 1, 1, 2, 3, 2. So I have quarters. I have 4 sections. So it's going to be a lot easier to graph this. And I did that on purpose because of my denominator. I have 4 sections in my fraction, or 4 parts to my fraction. So I chose to do a base 4 on my graph, just to help me graph it easier. So 0, 1. That's going to be 0, 1. Let me get the pink. I like graphing in that. That's going to be right here. And so that's that one. -1, +4. So -1, +4. It's going to be right here. I am not going to bother graphing that one because it's too high. It's too far up. I'm not going to reach it. 1 and 1/4 here. So that's that one. I got that one. And then 2, and then I'm going to do about 1/4 of the way. That's going to be 1/16. So then I can go from here down through these other points and get my curve. And there's my graph. So not terribly hard. I just scaled it up to make it a lot easier for myself to graph it. Okay, and if you do that on paper, like on your graph paper, so that you can actually see the shape and where it's supposed to hit and how you're supposed to graph it, then putting it into Jupyter might be a little bit easier once you've done that scaled up version. So you can actually see where everything needs to line up, just to make it easier for you. All right, so let's do one last one. This one's going to be a bit tricky. I'm just going to go ahead and clear the page. That's going to be easier. Here's our Cartesian coordinate system. And I'm going to wait and put my scale factor on there after we figure it out. So we want to, in 42.5, we want to sketch the function, or sketch the graph of the function y is equal to 1/2 negative x minus 2. All right, so we have an operation here. So we're going to separate these into two parts. So this is going to be 1/2 to the negative x, and then we're going to have 1/2 is going to be times to the negative 2. All right, so we can separate this negative x. We already talked about that. So that's going to be 1/2 negative 1 and then x. And then we know that this would just be flipped, and then this would be times 4, because 2 squared is 4. This would be flipped because of the negative 1. So this would become 2 to the x times 4. And this is our function. Now it's in a format that's a whole lot easier to understand and wrap our head around. Now we can start building our table. Here's our x. 2x times 4, and here is our y. Again, negative 2, negative 1, 0, 1, 2. So 2x, that's going to be 2 to the negative 2 times 4. So I'm going to flip this. So 1/4 times 4, that's 4 over 4, so the answer is 1. Here I have 2 to the negative 1 times 4. So when I flip this, it becomes 1/2 times 4. 4 over 2 is going to be 2. 2 to the 0 times 4, that's going to be 1 times 4. So this is going to be 4 instead of 1. So that's a change there. 2 to the 1 times 4, that's going to be 2 times 4 is 8. And 2 squared times 4 is 4 times 4 would be 16. All right, so I think what I'm going to do, because these are such big numbers, I'm going to count by 2's. So this is going to be 2, 4, 6, 8, 10, 12, negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, right? So this would be negative 2, negative 4, or not negative. Hello. Miss Tracy's losing her ever-loving mind. 2, 4, 6, 8, 10, 12. Just because I have such big numbers, 14, 16, just for the sake of getting all those in. And because they are whole numbers, are spread apart pretty good. So I'm going to use pink to graph this. So I'm going to start at the center like I always do on the y intercept point. So that's going to be 0, 4. So that's going to be right here. So that's that one. Now I have negative 1, positive 2. So it's going to be halfway between the origin and the negative 2. Half 1, halfway. So it's going to be negative 1, positive 2 is right here. So it's that one. Negative 2, positive 1. So negative 2, positive 1 is right here because that's halfway between 0 and 2. So that's that one. And now I have 1 and 8. Positive 1, positive 8 would be right about there. And then I have positive 2, positive 16. So 2 all the way up to the 16. So this is what my line looks like. It comes right through that 4 and arcs down and goes alongside the negative x-axis. And that would be how you would graph that. All right, not so difficult. Just remember when you have an operation here that you need to split them apart because it's two different things here. It's not so much a negative 2, it's a minus 2. But this is a negative x, so we split that. All right, that's all we have for lesson 42C. I will see you in lesson 43.